Hello guys, my name is Shumedha and this is my YouTube channel TECHEASY. This is my first video and today I will discuss about the construction and characteristics of JFET. So first of all, we have to know that what is FET? The full form of FET is Field Effect Transistor. The last term we are hearing, that is transistor. So we can consider that FET is a type of transistor, right? So today we are discussing about JFET. And about transistor, we all know in basic electronics, transistor is a very important thing in electronics. And transistor means transferable resistor. It's also point to be noted. So leave that. So today we'll discuss about JFET. JFET means junction field effect transistor. JFET is a part of FET. There is another part of FET, that is MOSFET. The full form of MOSFET is metal oxide semiconductor field effect transistor. I will discuss about MOSFET in another video. Okay. So first of all, JFET means junction field effect transistor. Here you can see that this is the symbol, right? Just look at the pointer I am showing. This is the symbol of any FET, like, okay, but it is for JFET. You can consider that. Now, those who have studied about BJT, okay, BJT is another type of transistor, and that is bipolar junction transistor. So those who have studied BJT, they also know about the symbol of BJT, right? So there we are connecting the arrow. You can show that, right? This is the arrow. In case of BJT, we are putting the arrow in the emitter side, okay, and in that BJT there is the base side, there is a collector, and there is an emitter, okay. In the emitter side we always put the arrow to show that this is the NPN transistor or PNP transistor in case of BJT, right? But today it is about JFET. So we have to know about JFET symbol, okay. In case of JFET symbol, you can see that the arrow is near about the gate. In the gate, the arrow is showing, right? Now, today we will discuss about only N-channel JFET, because JFET has two types. One is N-channel JFET and one is P-channel JFET, okay? So this is about N-channel JFET. And in case of N-channel JFET, this is the symbol. I will explain that how we can remember this symbol, okay? First of all, we can see the structure of JFET, so we can remember the symbol, okay? See this. See this structure. This is the gate side, this is the source side, and this is the drain side, okay? So we can consider that the JFET has three terminals. This is the gate terminal, this is the drain terminal, and this is the source terminal. Now, the point to be noted that this drain terminal acts as a sink of carriers. Okay, the drain is the upper portion of JFET. This terminal is situated above the upper portion of JFET, and it acts like a sink of carriers. In case of source, which is the lower terminal of JFET, it acts as a source of carriers, right? And in case of gate, Gate is responsible for controlling the flow of carriers. This is point to be noted very carefully, okay? Okay. So this is about the terminals, right? Now we are considering here about N-channel JFET. In case of N-channel JFET, what we can see that there is in the two sides there is two P channels, and the middle side there is one N channel, right? Now, in case of two P channels, you can see that there is creating a PN junction, right? There is created PN junction. So in case of PN junction, we all know that there will be creating a depletion region, right? So you can see there that's there is depletion region is created. Now you can see one thing that what is this terminal? What is this circuit? Why this is added? This is very easy. The answer is very easy because you can see that these two P channels are identical, right? And the two identical P channels means there is no reason to differentiate these two P channels. We can add them. It will work like similar, right? So these two P channels are added to the one gate terminal. Okay. Now you can see there that depletion region is noted there, and it's an N channel. Now today in this video we are discussing about JFET where the VGG. What is VGG? The potential difference between gate and the source. Okay, the potential difference between gate and the source is considered here as 0. Now the main point is we can consider VGG, that means this, we can consider as 0 or less than 0. What in case of less than 0 we'll discuss in another video. Today in this video we'll discuss about if VG is equal to 0. Okay, so in this circuit you can see that VGG is connected, but because of we are considering VG is equal to 0, find that source will be grounded. Okay, if VGS is 0 means there is no potential difference, right? So we can ground the source. Its source will be grounded. Okay. Now, what will be the construction? So, first of all, you can join the drain and the source, and there you can connect a VDD, another voltage source. This will be variable. Okay. That means you can increase or decrease the value of voltage. Now, there the current flow from drain to source. So the direction of current will be from drain to source. This in this direction. Okay. In this direction. Okay. This direction current will flow. And the current is called ID, drain current, because it is flowing through the drain to source, so it's called the drain current. And you can see there that this is the higher voltage and this is the lower voltage as source is grounded. So there will be the higher voltage and there will be the lower voltage. So obviously current will pass through higher to lower voltage. So you can see that. Okay. Now, firstly, I have said that there will be a depletion region in this picture. You can see that firstly because of there is PN junction, here a depletion, two depletion region in two P side is created, right? But in this picture, you can see that the depletion region is some kind of different, right? That you can see that here is the depletion region is very much thicker. But in case of lower region, the depletion region is not so much thicker. So why? The question will be arised. Okay, I will tell. Firstly, you can consider VDD as any of the variable, right? You can consider as if VDD will be 8 volt. consider as VDD will be 8 volt. So because of source is grounded, so the drain will be higher voltage and source will be lower voltage, and lower voltage means source will be grounded. That means there the lower potential will be 0, right? And the higher voltage there will be 8 voltage. So then the question arises, then that from 8 voltage it will be directly down to 0, or from 0 voltage to it is directly up to 8 voltage. Not like that. It will increasing continuously. Sorry, it will decreasing continuously, or it will increasing continuously. Like if it is 8 volt, then here you can consider it as 6 volt, is 4 volt, 3 volt, or like that. Here will be 0 volt, right? Now, because of there is the higher region, higher potential region, and in case of gate, here will be lower potential region, because you can see that gate and source is connected and source is grounded here. We have told that the source is grounded here, right? So because gate is lower potential and the drain is in high potential, so here a reverse bias is created, and in case of reverse bias the depletion region will be thicker. We have studied that, right? For this reason here the depletion region will be increased and will be thick. Same case of in lower region also, but in the lower region the voltage will be decreased to 0, tends to 0. So here the voltage region is very low. So here will also reverse bias will create, but not stronger than the upper region, right? Here the potential difference between the 0 volt and tends to 0 will not like that, not so much difference. So here depletion region will be created, but very small, not like upper portions. For this reason, this region is created like that. You can see that. Okay. Now, what is the work of VDD? You can see that this is the N channel, right? And the current passing through the N channel. The current passing through which channel is called the N channel, passing through the N channel. Okay. So in the first case, when we because we have considered VDD as a variable, so firstly when we increasing the value of VDD, so VDD will be increased like 1 volt, 2 volt, 3 volt, but after increasing, current will also increase. Current will also because of it is proportional to voltage, it will also increase. But you can see that with increasing of VDD, the depletion region will also increase, and the difference between these two, that the width is much smaller. The N channel will be very narrow. So we can see that it is a resistance, it is act like a resistance, right? That the current will flow from drain to source, but this type of region resists the current to flow, from drain to source. So what will happen in case of this? What will happen? But remember, these two type of depletion region never will be attached, never will be connected because of electrostatic repulsion. Okay, never will be, these two types never will be attached. So narrow, the depletion region will be narrow to narrow, very narrow, and the current one time at a certain time, because it is variable voltage, at a certain time current will be saturated. That means after that time you can increase the voltage, but the current will saturate. Current will not increase anymore. Current will saturate it. Okay. Why the reason? I hope you all understood. Because of the depletion region, this region acts like a resistance for the current. This resists the current to flow from drain to source. For this reason, at a certain time, at a certain voltage, the current will be saturated, and after that voltage, the voltage will be increased, but the current will not increase anymore. Okay. So it is about the construction. Now, here you can ask the question that because of VDD is a variable, so we can increase the VDD more and more and more up to when the current will saturate for a long time, for infinite time. You can think and answer me in the comment without see the next portion, okay? Because in the next portion I will tell the answer. I am silent here for 5 seconds to think, give you time that all of you think that after a certain time that we can identify the voltage in which voltage the current will saturate it, and after this voltage, after increasing, the current will saturate, current will not increase. But up to when time the current will not increase, current will be saturated for infinite time? It's the question, okay? If you can answer, you can answer in the comment without seeing the next portion of this video, okay? Okay, so now I will answer that. See, uh, after the voltage, when the current will saturate it, after some time the current will saturate, it's no problem. But one time will come when a breakdown voltage will come. Breakdown voltage means as a voltage after which the current will flow hugely. Hugely means there is an avalanche of. We have studied avalanche effect, right? That after a certain voltage there will be a huge amount of current flows through the transistor, right? So here in this case, in case of diode we have studied that. In this case, in transistors, same thing is happening, that if the voltage is increasing after that voltage in which voltage the current is saturated, and I am explaining that the voltage is called the voltage in which voltage the current is saturated, this voltage, that voltage is called pinch off voltage, okay? Pinch off voltage in which voltage the current will saturate it, this moment of voltage is called pinch off voltage. So after pinch off voltage, the voltage will increase and the current will not increase. But at a certain time, at a certain voltage come, when if the voltage come, the current will flow hugely. So this voltage is called the breakdown voltage, okay? This will be clearly more when we see the graph, the JFET output characteristics, okay? It is also called drain characteristics. You can see there, and you can see these two terms, very important: pinch off voltage and saturation current, okay? So you can see here that you can see this is ID and this is VDS, okay? So increasing with VDS, the current will also increase in this position, and this in this voltage, and in this position, from this position current will be saturated, okay? So this is the is means the saturated current, okay? But I am not mentioning there that what is the breakdown voltage. I'm just telling you, just listen, that it will saturate, but one time will come, one voltage will come, after which voltage current will flow hugely, infinitely current will flow. And that current, and that, sorry, and that voltage will call breakdown voltage, okay? I have written here this question, the what is breakdown voltage in JFET, okay? You can Google also that to clarify this more properly, but I just give you the concept that what is breakdown voltage and when it is occurring in this JFET, okay? So up to this is my lecture, and I hope all of you can understand. If not more properly, I think some of you also can understand this JFET, because after I have understood. I thought that I should also uh, teach some of my students, some of my friends, right? So hope all of you like it, and please go through this video once more if you have any uh, misconception about this video, or uh, any doubt clearness, you can write in comment section, no problem. Okay, in the next video I will post about MOSFET. Okay, so I will end the video is here. So all of you, stay safe, stay happily. Okay, bye, stay safe.